So this one, and Harvey, we can have Harvey and Scott, you all can do this one. So why don't we start with, we'll give it one more minute, but then why don't we start with, well, we will start with some of the recent things that were merged into master. I think that'd be a good starting point. And then we've got a couple of items from the community. Okay. So Scott or Harvey, do you guys want to kick off with any of the recent items that may have been merged?
Yeah, we can talk a bit about the 060 release. So let me include a link. Post it here as well.
Cool, I'll put it into the meeting notes, but I've got this item, this as the first agenda item.
Cool. All right, so the 060 release, which was cut 5 days ago, there's a few new notable features. One of them is we have a new failover service, CRD. And basically what that does is it provides the ability to create a new service entry that is composed of a list of services in priority order, descending. And each of those services also must have an outlier detection configured for it, and that's done through the traffic policy. And if the system detects that any of the services are unhealthy, requests will automatically be failed over to the next service in that priority list. And to do that, this is only supported on Istio right now, and we use the Envoy filter to sort of create an aggregate cluster in Envoy terms. That's how we achieve this. So yeah, that's the biggest new feature in 060, and we're curious to get some community feedback on it to see how it handles and whether there's anything we can extend or tweak about it to make it easier to use. Aside from that, there's just a few bug fixes. We have a breaking change. We renamed Zephyr to SMH in our group names, so it's a minor thing. There was a community question about upgrading Service Mesh Hub version 050 to 056. That's something we currently don't support, but it's on our roadmap.
So fresh install needed?
Yeah, I have to look into the details specifically. You maybe don't need to do a fresh install. You can probably keep some of your CRDs, but yeah, I would need to look into it exactly. But
do we have that? Do we have upgrade instructions in the docs at all? That would be...
No, not yet.
Okay.
We don't have anything for the upgrade path.
Got it. Even just a few tips might be good. And I'll take it as an action that maybe we could get a little blog out on this so that people are aware.
Sounds good.
Scott, do you want to talk a little bit about the refactor?
Yeah, sure. It would be great to actually, once we're a little bit closer along and we've finalized the architecture and the APIs, to publish something for the community, because we don't have anything like that yet. But I can give a rough overview. For the most part, it's an internal refactor, and it shouldn't affect things like user experience. Some of the APIs will be changing, but things should just be moved around. Everything that's possible today will be possible with the, whenever we release this, we'll do a bump of our minor version because we're still pre 1.0. And all the breaks will be noted there. We'll make sure to do everything we need to support migrating from the older APIs. But yeah, this is basically an attempt to greatly simplify some of the internals of Service Mesh Hub. It should make it a lot easier to contribute code for any of those who are interested in doing so, as well as making it easier for us to debug, iterate, there are certain things that I can give from a high level, like the statuses on CRDs are going to contain a lot of information about what the controller is actually doing. So bugs and things like that should be a lot easier to track down. Yeah, and we're just simplifying some of the internals, the way Service Mesh Hub interacts with different clusters, or how its interface works with multiple clusters. Yeah, again, it's not a huge user-facing change, but for any of our community who's interested in getting into the internals of Service Mesh Hub, there's a significant refactor going on, and maybe it makes sense to either publish a document or maybe have a section with some time to go over in more detail what that actually means for those who are interested in the internals.
Do you think that's, should we put that as is that something we can discuss next meeting, or when do you think that it would be ready for, to go and dig into some of the details with the community folks?
I think that within 1 or 2 weeks, we should be, at least we'll have the, within a week, I would say that we have the skeleton down for how everything's going to look.
Mm-hmm.
What I would like to do, if possible, is show, basically, in some of our older projects at Solo, we had some guides on here. If you want to extend the system, here are the files that basically you want to edit. Here's how to do it, with a little bit of a workflow for, what we call adding plugins or adding additional extensions and support. So if we have a place where those interfaces are defined and we can go through that, I would say to be on the safe side, 2 weeks, but possibly as early as 1 week for that. And if the community, I'm curious if any of our community members are have looked into the code itself and maybe contributing some features or to help guide, like what exactly do we want to showcase from the refactor? What is it that people would be interested in seeing? I would like to hear.
Make a note. Could it be framed in like a what kind of functionality areas the refactor impacts for people who may want to contribute things or build to Service Mesh Hub? I don't know.
But maybe you can talk about the plugins, and you can talk about the, the writing versus reading and all this stuff.
Yeah, sure. So I don't know if I want to jump into it right now, but basically there's a new architecture that we're approaching with, where we're trying to do all the, so Service Mesh Hub, from our point of view, it can be understood as a translation engine. Basically, everything that Service Mesh Hub is doing is taking from higher level CRDs, like a user defines a failover CRD, and we take that and we translate it into resources, for ISTL and other meshes that are presumably based on a declarative API of some kind, that we can translate to. There's some configuration for the mesh that we know how to operate, and then, we have this abstraction on top of it. So it's a translation engine. And basically what the refactor attempts to do is separate out the parts of the translation that the user or the use case is concerned with. So for example, if I want to set up failover, what I want to be able to do is have my failover CRD, all of the existing objects it needs to map to. So for example, an existing destination rule, existing virtual services, anything that's already defined in your system, whether it's defined by Service Mesh Hub itself or an existing, potentially, or I'm not saying that this is supported right now, but eventually we would be able to support a model where Service Mesh Hub is sharing configuration with that which exists in the cluster. What we basically want to do is allow users to come build a plugin. Let's say they want to add a new CRD or add a field to an existing CRD. That they can do that, modify our protobuf files, rerun the code generation, and then just add in a plugin, which is it adheres to an interface that adds the necessary config to an Istio service entry or a virtual service. So the plugins define the domain, but you don't have to do any wiring yourself. You don't have to go and create any Istio objects. You don't have to ensure that there are no conflicts. All of this heavy lifting stuff will be taken care of by the new system. That's the idea behind it.
Cool. So then what we'll do is, I've made a note in here, since this meeting's every other week, we can give an update. If you want to talk more.
I can give a really brief example if anybody wants to see.
Oh yeah.
Okay, so this is, just to be clear, this is a work in progress. So a lot of stuff is stubbed or unfinished, but I can show you here, if we look on the left side, I have the list of plugins that are currently implemented in this refactor. And if we look and say, I have an MTLS plugin. So the MTLS plugin is going to make decisions about how all the MTLS is going to be set up in your network. Now, right now, it's very lame. It just enables MTLS for everything. But the point is, what you'll see is it receives as an input reference to the service, and then a reference to the destination rule that corresponds to the service. So what you can do here in this MTLS plugin is you can make a determination without going, it's not wired up this way, but essentially what I could do is I could look at this mesh service, and I can look at the status. You have these applied traffic policies. Let's say I want to pull out of the traffic policy, and then, based on something in that traffic policy, I'll determine how to set up the TLS. And so basically what you have is a hook to the data, the input and output data that Service Mesh Hub is working with, and almost kind of like a filter, like an Envoy filter, you can act on those, on the output object and make decisions based on the input object in order to add functionality and behavior. It's similar to the model that we use to build Glue. This is just one example of how, if I, for example, I wanted to add a new complicated logic unit. Now I can make sure that I propagate this through, and when I process my destination rule, I can look at the value of that. We'll put it on the, sorry, I'm not the best at coming up with these off-the-cuff examples. This would presumably be an API object. You would add or modify an API object, and then you could take a look at that. Something, and we can make modifications on the output. So this is the interface that the user implements.
Hey, sorry for the interruption, but could you show the retries as well? Easy to wrap head around.
Oh, sure.
See multiple examples.
Yes.
Cool. Thank you.
So here's how the retry plugin works, and it's a bit more mature than the MTLS. So this is a good example. So the interface here for a traffic policy plugin is that you get a reference to the traffic policy. So the API for retries is defined in traffic policies. So we have an interface that accepts a traffic policy and the route that corresponds with the policy. And very simply, we translate the configuration off of the policy. We have an internal field registry. So you have to, this is in order to track conflicts and ownership of resources. so we can report the status properly. So you'll register the field. If registration is successful, you set the field, and this is pretty much how it works. So if you wanted to say, I mean, let's look at any object here. I want timeouts. I mean, we can do this together live, you know. Maybe it's a little too. The idea is something that's easy to copy paste. So I'll just do.
Is the plugin target service mesh specific? Because I do see Istio in the code, but not
Yes.
Linkerd.
Yes. So you will, you know, right now the plugin model is tied to each mesh. You'll have to implement this function, the translation function for each mesh. I mean, there's no, at some level, this has to happen. So if it's one plugin that implements multiple translations for different mesh types, or if you have separate plugins for each mesh, the interface would slightly change. So this function here, this process traffic policy, instead of the output being an HTTP route, the output would be, let's say, an app mesh virtual router, just for comparison. And then we can do the same thing. Then here we go. So I'm going to implement timeouts now. Press timeout. And we're going to return timeout. Let's look at what they want here. So it's a types.duration. We'll do types.duration. Actually, let's see what our type is. Oh, it's already a types.duration. So we can simplify this a lot. Let's just return this and nil. Very nice. And now we're already, you see that our plugin's already implemented. So you can just basically copy paste an existing plugin like what we have over here on the left. And then the last thing you need to do is add an import statement for it. So it gets picked up by the Go compiler. We'll just add timeout here. And now our timeout plugin is added without having to modify any of the translator code directly. Yeah, sorry, I hope I didn't take up too much time with that.
So the idea maybe to explain you why we're doing what we're doing. I mean, we worked a lot with customers, and what we're discovering is that, you know, everybody has their own need, their own request, and usually, you know, what's beautiful about the system that we're building is that you can do this by actually, you know, have the right hooks in Envoy or in the service mesh, something that we're using a lot, like Envoy proxy filter proxy in STO, and basically we'll be able to extend it. So you know, because we want to make sure that people will be able to extend it to their own use case, and rewriting a lot of those for people that are interested in our customers, it was very important for us that it will be very, you know, as simple and fast as we can do it. And that's basically what the system is trying to do. First of all, it's cleaning up a lot of stuff. It's making everything way more stable. And in the nutshell, it's basically letting you focus on the business logic instead of how to pipe the system. So that's basically was the idea of this. And again, we did it in previous project for us like Glue, and it just make it go really, really fast. And then you can deliver very, very fast. So that's basically was the idea behind it. Does it make sense?
Would it be accurate to say that it speeds up the use case where a single service mesh type, you want to add functionality to it without having that without SMH requiring you to have some form of that functionality in the other service mesh types, or there's no required, I guess, stubbing out or whatever of the functionality in service mesh types that don't support that corresponding action? Or is this more just a pure, you know, API, I guess, mechanism for leveraging the specific API interfaces that a Service Mesh Hub defines, and just adding functionality underneath the specific Service Mesh type. Sorry, getting too many service meshes in my.
You'll be able to, so the piping under the system will automatically handle which meshes are supported by a plugin or a policy. So this definitely simplifies that.
Yeah.
work.
It simplifies that, and it also simplifies, as you said, the ability to actually add feature to the meshes. As you know, this ecosystem is very fast growing, and there is a lot of service meshes that just starting, like for instance, Puma, that they don't have all those functionality. AWS is adding a lot of functionality. So we want to make sure that we will be able to as fast as they adding it, very quick adding it. Now, from our experience, when we're doing it in, different projects of us, this model works so well that we could do a feature in a matter of day. And it will be very solid because the system itself is very solid right now. It's very, very robust because you don't need to worry about that. So then you can go and without make sense of all the system, add a very simple feature and it's just going to work. So I think it's first of all, at least for us inside Solo, it's taking the velocity insanely high, right? I mean, we can actually ship way faster. And I think it's important. So that's helping us with question of what will happen right now if STO is going to come on 1.6 and the API will change? Or what if they will add new feature on 1.6? We can just basically go very, very fast and make sure that we are basically keeping up, up to speed with upstream in every mesh. And then as you said, I mean, generally, the system is built like this, that we are only supporting the feature of the service meshes that the service mesh themselves is supporting. So like, for instance, if Kuma is not, whatever, if AppMesh is not supporting circuit breaking, we are not going to do this, right? We're not going to support that. So that's already built in to this system as well. But mainly, again, the velocity and how quick we can actually add feature, I think, and again, without unstabilize the system, right? There's only one place that you need to do this. I think this is the big thing here. And as I said, we had a huge success with this architecture. This is why we decided to bring it here.
I think one helpful way to think about it is the Service Mesh Hub interface is a superset of all of the possible features that exists in the service meshes that we support. However, I think you asked a question about like lockstep. We don't actually have to implement our mesh specific features in lockstep with each other. So if one of the meshes has a feature that you want to leverage and you're only interested in that mesh, you don't have to worry about the other meshes not supporting it or having to like stub out and not implement it for those meshes.
Yeah, I think I'm still trying to, I'm still trying to understand exactly how Service Mesh Hub works in that way, like where you have the kind of intent of what you want to do, exposure of service and traffic policy wise, and then carry that out in the individual service mesh types. Like how, I think to some degree it looks like the implementation is very like targeted at, if you want to have this service, like an Istio service mesh that has a ton more capability than like a Linkerd service mesh, and you just want to have multiple Istio service meshes under your SMH umbrella, we have a ton of features for you. That seems like more the use case that you guys are going for than sort of the normalized API that will somehow give you the least common denominator support if you do bring in a Linkerd API. And I think that some of this is just my not understanding it completely. So I'm just trying to think it through.
So I will say that basically what's driving us, what will be the next feature or what are we supplying is basically requested by the community and by our customers, right? I mean, basically what people want and what we see in the field, right? I mean, if everybody using STL, yeah, we will give way more love to STL because that's what everybody's using, right? Not because this is, oh, it's more reach, so we will be able to do this, right? It's basically driven by the market itself and not by what we want per se, if it makes sense.
Yeah.
But the idea, the vision itself is definitely not to do the lower common denominator. This is one thing that I really not think that we should do. We should go in the fastest, right? We're all about innovation on the fastest pace of the fastest mesh, right? We should make sure that we basically getting all the features. That's number one. And number two is we're going to add a lot more meshes. Like, I mean, Kuma is the one that we're going to do, and UpMesh is already supported, but and also Linkedy. Console is the next one. So, I mean, the idea is that we totally believe that in the future, they're going to be, potentially, you will want to run something on-prem and then want to go, for instance, to UpMesh, and it will make a lot of sense to you to use this because it's natively going to run there. And therefore, we want to make sure that we are grouping them together to virtual mesh, and you can actually act as one big mesh. So that's kind of like a big one. But of course, if we're doing all of this and we're basically coming with this API on top of it, that all the meshes are talking, and also the fact that we have, all the virtual meshes, now what will be interesting is what we can leverage from this, what we can do on top of it. And I think that there is tons that we can do in the multi-cluster level. And I think that would be very interesting. Stuff like, failover, routing based on the localization or based on user. That's the stuff that I think that in the nutshell, that's what we're hearing that people are interested in. And again, we would love to hear what you guys are interested in.
Yeah,
right?
that intersects with more with what we are interested in, I think, at Cisco. I mean, we are interested in the, I guess, sort of the agnostic service gateway kind of model. And I think that, but we want to add value like underneath a little bit. So we are probably going to have a proposal at maybe in time for the next meeting about how we could integrate at the very first step, I think, would be to integrate an alternate service discovery mechanism into Service Mesh Hub with some, and it may be just exactly the use case that you guys are talking about for incorporating new service mesh types. What we're talking about is not really a service mesh type so much as a sort of a connectivity layer that has awareness of services. So we're probably going to have some proposal soon on getting a sort of experimental feature, but what would, I think we want to work through the process with the community on trying to get that exposed to the community as early as possible, and just work on the implementation as we work on the overall solution as well. So I don't have all the details for that right now, but that's just a stay tuned thing from our side.
Yeah, I know, we would love that, as I said. Yeah, definitely. And as you said, I mean, there is a lot more work to do. We should go also to VMs, not only services.
Yeah, exactly. That's sort of the approach that, so we're I don't know if you've heard of the network service mesh project, and it's a sandbox or incubation project in CNCF and Cisco. We are one of the main sponsors, and so the work we've been doing on my and John, Joyce, and Dominic's team is working on a solution based on that project. For the initial thing is just some multi-cluster service interconnect with varying, we have varying network function types that that will provide that interconnect, and some features on top of that. And then we want to have like the integration with Service Mesh Hub to give us that tie-in with the service meshes that are actually sort of locally owning those services, and have that kind of the same kind of gateway model, but with our essentially our network functions as the actual traffic path, and so that's the high level of what we're talking about.
Oh, that's awesome.
May I ask a question?
Yeah.
So you're talking about plugging in more service discovery types into Service Mesh Hub.
Yeah.
Are you familiar with the concept of the mesh service that we have today?
Yeah. So I think underneath, so the implementation I'm not familiar with, but maybe there's other guys on our team that are more looking at the implementation details, but yeah, that's.
So I'll give from a high level what it's about is basically you have any number of service registries that you want to connect to Service Mesh Hub.
Mhm.
You know, it might be Kubernetes as a service registry. Cloud Map is a service registry. In AWS, Console is a service registry. The mesh service has the potential to support all of those, as well as external services. So if you want to bring a service registry to Service Mesh Hub, it should support that. And if you want to use Service Mesh Hub as your service registry directly by creating your mesh services manually, that should also work.
Yeah, I think that's, so we were thinking, I think our initial proposal probably would be to create mesh service objects in via a client of the interface that we have. But we were also, prior to this work, we were looking at integration with Istio more tight, and we were thinking of maybe an MCP server implementation, or you know, and so that was how those were the avenues that we've been kind of exploring a little bit. So, but yeah, so you're recommending go to the mesh service interface or mechanism.
Well, my question is, the services that you want to discover, are they already stored in some kind of registry, Zookeeper, Console, etcd?
No, we are so the thing we are implementing is a service registry effectively. So it would be a new type of service registry from SMH's point of view.
I see. Yeah, so we would, so we can get more into what the implementation would look like, but essentially, I could see a plugin for the discovery mechanism, which basically takes arbitrary data from an endpoint that Service Mesh Hub doesn't know about. But your plugin does. Your plugin knows how to connect to, read from that, and then produce mesh services. And then the discovery component, what you'll be able to do is provide a credential or whatever it needs in order to connect to that backend. I mean, this is how I would see it working.
Okay.
And then Service Mesh Hub would automate importing those services from that backend.
Right. Okay. Yeah, I think that sounds like the most obvious way to implement it. I think the thing that we would still, I'm not sure if we've figured out, is the in the traffic policy, yeah, like our thing is not actually a service mesh, right? It's it's more of just L3 connectivity. You could think of it like that, between it's like almost like an L3 subnet that's reachable for specific workloads, or between specific workloads. So from the point of view of a workload that's in that service that was discovered, the other services that it would be either clients of or providing services to, that's the the spectrum of services that would be coming from our service discovery component. And so then how that maps to reachability, how SMH maps, reachability from the other service mesh types is something that we would probably have some either questions on or proposals to possibly change, add changes to.
Makes sense.
Fantastic. Sounds great. Tim, do you have any other features or some ideas that you have that you might interesting to see integrated with Service Mesh Hub, or you want us to focus on?
Well, I had a question, or maybe it's in line with some of the issues. It's more like this is just more how operationally to use Service Mesh Hub in the cluster registration. It doesn't really solve any of the problems that we have with like having access to a Kubernetes, like a generic way to, or I guess multi Kubernetes cluster type kube config, usage, right? There's a project called Admiralty that I referenced in the notes that describes the problem pretty well. So I was wondering if you guys had looked at any of that stuff, or if that's a thing that is just a something that somebody needs to tackle, or you want to punt it for, not have the Service Mesh Hub project solve that. It just would be a client of something else that would solve that.
Can you explain a little bit more about the problem that you're trying to solve? The registration of the cluster or the management of?
No, yeah, it's so. For example, the mesh or cluster registration requires adding a kube config for access to the API server for a specific cluster, right? And that kube config, like none of the Service Mesh Hub documentation indicate like what the requirements for that kube config are. So a user of like EKS, for example, wouldn't be able to just take an EKS kube config that they use on their Mac and drop it into Service Mesh Hub and have it work, right? Because the IAM integration portion is not installed, and the identity that is actually associated with the IAM utility that's running that kube config triggers, or kubectl would trigger, isn't in the pod where that Service Mesh Hub mesh or cluster registration discovery thing is running, right? So
1 sec here. I think Harvey, correct me if I'm wrong. Do we create service accounts, or do we add the config verbatim?
We create a Kubernetes service account. So I can clarify a bit how it's working today. At registration time, when you run meshctl cluster register, the kube config that the user is using has to have a certain level of permissions. I think currently we just have cluster admin permissions, but we could scope that down in the future. So when they execute that command, they use the cluster admin permissions to generate a new service account on the cluster that's being registered.
Okay.
And then the bearer token for that new Kubernetes service account is then copied over into, exactly. Yeah.
Okay.
So
yeah, I don't think I was
sense,
clear on that from the documentation. Okay, cool. So it actually is, mesh CTL is actually required in that path, right, to trigger the service account creation. Okay.
Right.
I got you.
And so the kube config that the user is using, that's only a one-time thing.
Gotcha. Okay.
One thing I would say is if we want to make it something declarative that doesn't involve meshctl, it's doable. You know, another option is a job. So if you wanted to kubectl apply a job, that would do the necessary work for us. Or even to just have the objects, you know, pre-created. Because I think there's an understanding that, you know, we don't want necessarily to force an imperative flow. If you have a cluster set up, it sets up 10 clusters, so you want to automate that.
We actually have that right now for EKS. We have a notion of declarative cluster discovery, and it uses the AppMesh API to list, or rather the EKS API to list all of the clusters available in a region for a given account. And you can tell Service Mesh Hub, like, I want these clusters to be registered.
Yes, so I think that basically the problem is mainly docs. And the only thing that I can tell you is the resource of the docs is just wrapping up something, and then that's you will come to clean up a lot of the docs. So we're going to do a lot of love for these docs.
Yeah, no, so that's good. I'm glad that I figured there was some level of solution that I wasn't understanding, but yeah, okay. Yeah, I think just clearing up the documentation, especially, I mean, or at least have the mechanism for drilling down, right? So like a pointer to even something that's more code-like would be fine.
Yeah, and if you have these concerns in the future, feel free to reach out to us in the community Slack, and we can provide an immediate answer. And then if you want documentation, or if other members of your organization want it, we can prioritize writing a quick article or something about it.
Yeah, I think this is the type of thing that, I mean, we should, like, we're trying to build up like some contributors to SMH. So this is the kind of thing that, you know, we could, you know, carry water, chop wood, type of thing for this. Just it was something that I thought of when I was going through the examples demo stuff. So, and we ended up, like, at the time, it was a while ago, it was probably like a couple months ago, I did a lot of the kind work for our team, so I had a lot of the comments in one of the issues on the kind integration. So.
Yeah.
Do we want to go through the 2 questions that are in here? That are also in the doc?
Sure, do you want to share it or do?
Yeah, so the one is, there's about a Vault CA integration, and that came from Andre Carlson. I don't know if any of you all have talked to him on Slack about that.
Let's see.
Harvey, Scott, or you, Paul?
Vault integration. I have not spoken to Andre about that.
So my guess is that this would be to allow us to wire up. We have a config right now on the virtual mesh that allows you to specify the certificate authority for your mesh. And currently we just allow you to reference a secret, I think. Theoretically, we could extend that to support Vault as well as a source of secure certificates. You know, I think it would boil down to modifying the code, modifying the API, and then a plugin. The new model should support it. But we did something similar for Glue. So I think that we would know pretty straightforward how we could wire that up.
Yep.
Please file an issue. Well, that's going to file an issue so we can at least track it. And Dominic, you've got the question here. This started with the identity management, identity of the cluster instance. And then you've,
Yeah, so I was curious about the how the cluster instances are identified because in my early experiments with it, I was able to register a cluster twice. So then, of course, the workload instances and mesh instances were discovered twice. So I was curious about the what is the anchor of identity for a cluster, and then therefore for the services.
It's a very good question. So currently we don't have one. And if
Yeah.
you know, Kubernetes itself doesn't have any notion of identity for clusters.
Mm-hmm.
One of the changes that we have coming for cluster registration is what you register a cluster. You'll be registering it. There's a CRD that corresponds with the cluster, and the CRD represents the identity of the cluster. And we can verify that. I mean, the thing is that at registration time right now, we require some kind of string identifier in order to differentiate the clusters, because
Mm-hmm.
there's really no way, unless we use some kind of heuristic, we can't actually definitively say whether this is a new cluster or it's the same cluster being re-registered. Right. I mean, one of the things I would say is maybe we can use the IP address of the API server and say if it's the same API server, it's the same cluster. Maybe that's a good enough heuristic, but I think right now what we went with was, you know, it's a bit more fragile, but because we don't have a definitive source of truth on that, it's more difficult to enforce.
It's not that I have an answer for the question, but I would not necessarily go with the API server. I know it's typically done that the external address of the API server is the identity anchor, but I mean, you can have multiple API servers in a high availability scenario, right? So
yeah. I think that, you know, we're tracking the work that the SIG multi-cluster group is doing in Kubernetes. And this is something that they're focusing on addressing as well, cluster identity. So if the community can reach a larger consensus on how to do that, I think that would be the most preferable path forward, as long as it's a good solution. But so far, I think the work that's come out of the SIG multi-cluster has been at least a good guideline. So there's definitely this problem. It's not only our problem of how to uniquely identify clusters.
and
Yeah.
then because sorry, Tim, go ahead.
I was just gonna say, I mean, on the SIG multi-cluster point, I haven't been following the KEPs like super closely, but I did come across one with a multi-cluster service API that had exactly kind of this problem as well. So, and it's a proposal for CRDs, or a model for having a multi-cluster service definition and having a service export and import sort of semantics across multiple Kubernetes. So separating the service concept from the cluster level. And it had but it did have a cluster identity sort of problem inside of there.
So from my point of view, I have to say one of the nicest things that that Service Mesh Hub does is give a Service Mesh instance an identity, because also Service Mesh instances don't have identities, right? They're implicit. So with the mesh object or mesh CRD, you're actually giving that an identity, which is pretty cool. But that hinges on the cluster identity, right? And that is still fragile. But I understand that is a common problem. Yeah. But then that fragility basically translates all the way to the mesh identity in Service Mesh Hub.
Yeah, I mean, I could think of one, you know, an approach that might be useful, which is once a cluster has been registered, trying to think, can make it so that once a cluster has been registered, we can assign it a unique ID, and further attempts to register the cluster will cause an error, so that we can ensure that every cluster has only been registered once.
Could you persist some storage to that cluster?
I mean, we already do that, right? We create the service account, we create the namespace for the service account. So I think that we can use either one of those as like a global identifier for the cluster, and then just choose to error if we, when we try to create, if we see that it's already existing, we just error out.
Right.
For the service account, you could use the UUID that is associated with the objects.
Mm-hmm.
Sure.
It would basically translate to, if somebody deletes the object and recreates the object, it is considered to be a new cluster.
Mm-hmm.
But it may be a fair assumption, that depends.
That's a good point.
So eventually it is, we have to ask the question anyways, what is the same thing, right? So, I mean, that's a philosophical question. Am I still the same person after I cut my hair? Or can I jump into the same river twice, right? So eventually there will be the question, is this still the same cluster? But if you stick to the service account, taking the UUID, then you at least cannot double register at the same point of time, right? You may make the mistake over time to think that quote unquote the same cluster is a different cluster, but you cannot double register. And after the cluster is done, you can definitely clean up the service mesh instances and workload instances that point to the old UUID and basically just rediscover it for the new UUID. So you do not really have an overlap problem.
Yeah. We could also, the bundle that we use to connect to the cluster is a kubeconfig that we generate from the service account. And I'm trying to think if there's some way that we could actually use the bytes, like a hash of the bytes. Maybe not a hash of the whole bytes, because that can change. But yeah, no, the service account is probably the best thing.
Another interesting question this raises is internally in Service Mesh Hub, a cluster is just identified with a string. And I can see advantages and disadvantages to doing that. Like say you have a bunch of configuration that targets a cluster with a certain name. That name is like a loose identifier. Maybe under the hood, you want to swap that cluster out for a different cluster, and you don't want to rename all your CRDs to this new cluster name. So you could keep the same string identifier, but it's now pointing at a new cluster. That's one advantage I see, but not sure how realistic that use case is. Does that make sense?
Yeah, it does, I think. I just don't have a use case.
So one thing I'll say is,
Really,
is that
mapping through it, really.
the current cluster registration model hard couples the identity of the cluster, its name with the secret we use to discover the cluster. But with the introduction of the Kubernetes cluster CRD, which will be our official, the cluster name can be populated right in there. And then, if you want to change the cluster name or swap them, you would theoretically be able to just edit that object, but it's not supported today. So I think we could do it. I think that cluster actually does make sense to have as a string, because from the point of view of Service Mesh Hub, a cluster is like a namespace. So namespaces are a string identifier. A cluster is a bucket of namespaces, and the namespace is a bucket of resources. So I don't know that we need to, imagine if you moved something to a different namespace rather than a different cluster. It'd be exactly the same process you would have to consider.
There
we
is one more. Oh, sorry.
No, I was saying, go ahead, Dominic. I was just wanted to give everyone a little time check.
Oh yeah, no, actually, mine would lead us down a rabbit hole that exceeds 2 minutes. So it's like we just delay that.
Dominic, why don't you why don't we add that to the notes for next time?
We'll do that.
Yeah. Okay, sounds good. So then we can start with the rabbit hole in 2 weeks at the next meeting. So we'll kind of do that earlier on, so we have lots of time to discuss. Thanks all for joining today, and let's see. Links are in there for the new release and such that Harvey talked about, and Scott will also kind of do provide an update on the refactoring, and then we can, any other questions that come up, we can do that. All right. Thanks everyone. Thanks for joining. Have a good day. Talk to you next time.
Thank you.
Bye.
Thank you. Bye-bye.
Everybody.